Hello guys, welcome to H2O, the A to Z of chemistry. I am Dr. Ritu Johar, your educator for this course, the atomic structure. Today we will begin with lecture 12 from the course, but make sure you have watched the previous ones before viewing this one. In the last lecture, we discussed about the hydrogen spectrum. Well, as we discussed last time, hydrogen atom has the simplest line spectrum and it becomes more and more complex for the heavier atoms. But there are certain features common to all line spectra. For example, the line spectra of each element that is unique. There is regularity in the line spectrum of each element. But the question which arises is that what are the reasons for these similarities? Has it something to do with the electronic structure of atoms? Well, Niels Bohr was the first to explain quantitatively the general features of the hydrogen atom structure and its spectrum. So in this lecture, we would be discussing about the Bohr's atomic model. So Niels Bohr, he was a Danish physicist. He has even worked with Sir J.J. Thomson and Rutherford for about 1 year, and he gave his atomic theory in the year 1930 to explain the existence of the line spectra and the stability of atom. He modified Rutherford's atomic theory with the help of Planck's quantum theory, and the postulates of his theory are the first being the entire positive charge and most of the mass of the atom, they are concentrated in the nucleus with electrons some distance away. So this is exactly what Rutherford had also said, that the whole of the positive charge and the most of the mass of the atom, the electrons being of negligible mass. So they are concentrated in the center, that is called as the nucleus, and the electrons, they are some distance away from the nucleus. Then the electrons, how are they placed? They are moving in concentrically arranged circular paths of fixed radii and energy, and these circular paths, they are called as orbits, stationary states or permitted energy states, and they are moving around the nucleus just like the planets they are doing around the sun. They are not radiating any energy while they are moving in these concentric paths. So each electron, when it is on its orbit, it is not losing any energy. That is what Bohr said. So the second postulate is that each energy state is associated with a fixed amount of energy, or this is called as an energy level. So this energy increases with increase in distance from the nucleus. The letters K, L, M, N or numbers 1, 2, 3, 4, they are used to designate these energy levels. So these orbits, they have fixed energy. Okay, so they are having the first shell, this is going to have some energy. The second shell, this is going to have some higher energy. So the least energy with this K shell, then with the L, then with the M. And otherwise, if you count them 1, 1, 2, 3. So the first from the nucleus would be 1, then second and third and so on. Fine. So this is how he designated the energy levels. So the third postulate is that the energy of an electron in the orbit does not change with time. The electron in an orbit, this has a fixed amount of energy. However long it may continue moving in its own orbit, there is going to be fixed amount of energy. It is not going to change. But when the electron, this moves from a lower energy state to a higher energy state, it will do so after it has absorbed some amount of energy, right? So if an electron is present in this E1 orbit, which is the lower orbit, if some energy is given to this, it absorbs that energy and then it will be moving to the next energy level. So the amount of energy absorbed is going to be how much? E2 minus E1, right? And E2, this has a higher energy than E1. And then if it has to come back now from the higher energy state to the lower energy, it is going to emit that much amount of energy in the form of electromagnetic radiation. So that is what we studied in the emission spectrum, right? You remember? So the electron, when in the higher energy level, coming back, because it is unstable, coming back to the lower energy level, emitting radiation in the form of electromagnetic radiation, and that energy is again going to be equal to E2 minus E1. And the energy state, this change does not take place in a continuous manner. So now you know, whenever transition occurs between two stationary states, when an electron is going to move from a lower energy state to a higher energy state, energy is absorbed. When coming from a higher to a lower energy state, energy is being emitted. When it is being emitted, you know it is done in the form of electromagnetic radiation. And if it is an electromagnetic radiation, that means it must have a frequency also. And we know the relationship between energy and frequency from Planck's quantum theory. What is that? Yes, E is equal to h nu. So we can calculate the frequency of the radiation absorbed or emitted when the transition occurs between two energy states that differ in energy by delta E. And this is given by nu is equal to delta E by h, and delta E is E2 minus E1, where E1 and E2, they are the energies of the lower and the higher allowed energy states respectively. And this expression is commonly known as BOHR'S frequency rule. The next he gave was that the angular momentum of an electron is quantized. Quantized meaning it is fixed. In a given energy state or a stationary state, he said that this can be expressed as mvr is equal to nh by 2 pi, where m is the mass of electron, v the velocity, r the radius of the nth orbit in which the electron is moving, and n is 1, 2, 3 and so forth. Now, do you know what is angular momentum? Well, it is just like linear momentum, and as linear momentum is the product of mass into velocity v, linear velocity v, angular momentum, this is the product of moment of inertia I and angular velocity omega. So this is concept which is coming from physics, which if you've not studied till now, you will be doing it shortly in class 11th only. And for me, for an electron of mass m moving in a circular path of radius r, the angular momentum, this is given by I into omega. And again, physics tells us that I is going to be equal to mr square and omega is going to be v by r. So what would be angular momentum? I into omega. So I is mr square, omega is v by r. So multiply both of them, you get angular momentum to be mvr. And what did Bohr say? He said that the angular momentum of an electron, just like energy, this is quantized, this is fixed, and the value it has is a multiple of h by 2 pi, and hence it is nh by 2 pi. So what does this mean? Well, an electron, he said, that can move only in those orbits for which its angular momentum is an integral multiple of h by 2 pi. So if it has to be an integral multiple 1, 2, 3, only those orbits would be allowed. If the values coming up are not integral values, not whole digit numbers, so they will not be allowed. Those orbits will not be allowed. So that's meant that the angular momentum is quantized, and radiation is emitted or absorbed only when the transition of electron takes place from one quantized value of angular momentum to another. So when will radiation be emitted or absorbed? When it is moving from one energy level to the other energy level. In between there is going to be nothing, right? So therefore Maxwell's electromagnetic theory does not apply here. That is why only certain fixed orbits are allowed, right? So I hope this is clear that the angular momentum is quantized, and the electrons, they can move only in the orbits for which the momentum is integral multiple of h by 2 pi. So this is very important. So what is the fundamental difference between Bohr's atomic model and the Rutherford's atomic model? Well, Bohr's atomic model, it is based on the concept of quantization of energy and angular momentum of the electron. And according to Bohr, the electron can move only in certain permitted orbits associated with some definite amount of energy and angular momentum. And Rutherford's model, it does not give any idea about quantization of energy or which orbits or stationary states are permitted. So that would be the difference, and I hope you can appreciate what this is mean now. So the Rutherford's model failed because his atom was collapsing. And how did Bohr explain that why an atom does not collapse? Well, he said that since energy cannot be lost by an electron continuously, an electron continues to move within a particular energy level without losing energy. And such a state of atom, this is known as normal or ground state. So the first thing is that the electron is not losing energy continuously. And the second thing is that an electron cannot radiate energy if no lower orbit is available. Therefore, the atom does not collapse. And then why spectrum is formed? He said that on gaining energy from an external source, the electron jumps from a lower energy level to a higher energy level. Such a state of atom, this is called as excited state. And however, being unstable in the excited state, the electron drops from the lower energy level by losing energy in the form of radiations of appropriate wavelength. And this accounts for the formation of the characteristic spectral lines in the atomic spectrum of a particular element. So I hope this is all clear to you. So that would be all for this lecture. In the next lecture, we would be discussing about the mathematical expression of Bohr's model. If there has been any difficulty or anything that you would like to share with us, please do mail us at h2ochemistry@gmail.com. We would meet again for the next lecture from the channel H2O. So now if you like the lecture, please do click on the like link and also do subscribe to our channel and click on the bell icon also so that you get a notification as and when we put up a new lecture for you, a new course for you. So bye, have a nice day, enjoy yourself, enjoy your studies.